All right, guys, so I'm going to go ahead and do a quick example for a dihybrid cross. So a dihybrid cross is where you're looking at two traits at the same time. And why this has to do with the law of independent assortment. What was a brilliant idea that Mendel had, which was basically to cross two of these pea plants and look at two of the traits and to see if one trait was dependent on the other trait to being passed down. In other words, if one trait was linked somehow to another trait, if the genes were linked, if they were passed on in a pair, if that makes sense. And so the way he did this is he went ahead and he looked at two traits at the same time. So why don't we look at two traits at the same time? So a dihybrid cross, remember a monohybrid cross is looking at one trait, but a dihybrid cross is looking at two traits at the same time. So if we looked at what Mendel was looking at, he was looking at pea color, he was looking at pea shape, he was looking height of plants, pea plants. So let's go ahead, sorry guys, a little late, excuse me. Let's go ahead and take, let's say he was looking at round, which is dominant, versus wrinkly, which is recessive. And he was also looking at the trait, and this is a very common cross that we're doing, yellow peas, and green. And yellow is dominant, and green is recessive. So let's say he did a cross. Let's set up a cross of he had round, wrinkly, yellow. He had round yellow peas, both of them hybrids, crossed with round yellow peas. Okay, so how are we going to set this up? So first off, the phenotype here is round, and the phenotype here is yellow. The phenotype here is round, and the phenotype here is yellow. Okay, so let's set up this. So just like a Punnett square, you're going to have to divide these traits out and look at the various combinations. So we had round yellow peas, and it was heterozygous. So the big question was, how does the aluminum foil interact, or what does it have to do with today's lesson? Well, foil is a math term standing for first, outer, inner, last. So we're going to have to do that exact thing for our square here, for our dihybrid cross, in order to get all of our possible combinations. So we've got 1, 2, 3. That gives me 4 this way, and 1, 2, 3. So I have a 4x4 or 16. So remember, I'm going to do this one first, and I'm just going to put it here. It doesn't matter if I put it here or if I put it here. And then afterwards, it's the exact same thing. So the next one, I would redo it and just put it on here. So let's do the first. So first. So my first is here. So that's going to be capital R, capital Y. My outer, sorry about that, guys. My outer is going to be here. So that's going to be capital R, lowercase y. Then my inner is going to be here. And that's going to be lowercase r, capital Y. And then my last is going to be here. And that's going to be my lowercase r and my lowercase y. So those give me the 4 combinations of genotypes I could possibly have for my R, capital R, lowercase capital Y, lowercase y. So I'm just going to write the exact same things here. Okay, so what am I going to get? So let's do this. I got capital R, capital R, capital Y, capital Y. Okay, so over here I've got capital R, and I've got capital Y, lowercase y. And the next one I have capital R, lowercase r, capital Y, capital Y. Then I have capital R, lowercase r, capital Y, lowercase y. The next row, I'm going to have capital R, uppercase Y, lowercase y. Then I'm going to have capital R, lowercase y, lowercase y. Then I'm going to have capital R, lowercase r, capital Y, lowercase y. Then I'm going to have capital R, oops, daisy, capital R, lowercase r, lowercase y. And then I'm going to have capital R, lowercase r, capital Y, capital Y. Then again, capital R, lowercase r, capital Y, lowercase y. Next, I'm going to have lowercase r, capital Y, capital Y. Then I'm going to have lowercase r, capital Y, lowercase y. And then I'm going to have capital R, capital Y, lowercase y. Then capital R, lowercase y, lowercase y. Whoops, sorry about that, guys. And then I'm going to have lowercase r, capital Y, lowercase y. And last I'm going to have lowercase r, lowercase y, lowercase y. Okay, so we've already said that the round was dominant, because that's the capital R. Let's look back up here. So the capital R, round is dominant, lowercase r is wrinkly. The yellow is dominant, lowercase y is green, it's recessive. So if I come and I just put some colors on this. So I'm going to go and get some yellow, and let me make it kind of bigger here. So yellow. Okay, so the first one is going to be round and yellow. The second one is going to be round, and we got the dominant yellow there, so it's also going to be round and yellow. The third one, well, it's got dominant R for round and a capital R dominant for yellow, round and yellow. The fourth one, even though it's heterozygote, yep, they're both dominant for round and yellow. So I got another round and yellow. And then the next row, again, I've got dominance for both round and yellow. And the next one, I have round and green. I've got a dominant for the nice round smooth, but my color of P is going to be green. And the next one, I have again round and yellow. And then the next one, I have round and green. Then down here, we've got round and yellow again. And then next to that, we have round and yellow again. And then we have wrinkly and yellow. So my P is going to look like this. And then I have wrinkly and yellow again. And then I have round and yellow again. And then I have round and green. And then I have wrinkly and yellow. And then I have wrinkly and green. So what's this show me? Well, this is a typical dihybrid Mendelian cross. And if I look at a typical dihybrid Mendelian cross, I'm going to get a ratio that is 9 to 3 to 3 to 1. That's when I'm looking at a hybrid going across this way and a hybrid coming across this way. These were both hybrid crosses. So what do I mean by 9 to 3 to 3 to 1? Well, if I count these, let's see how many round yellows I have. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that gives me 9 round yellow. Okay, well then, how many yellow wrinkly ones do I have? 1, 2, 3. And how many green round ones do I have? 1, 2, 3. And then I have 1 green wrinkly. All right, so you can see when I look at it like this, I have 1, 2, 3, 4 genotypes. But if I look at the phenotypes, I have significantly more phenotypes, don't I? So we've got 1, sorry, I don't know what I just did.